So let's move on now to student note 2.6, rotations. So this is lesson 6, unit 2. We're going to start this lesson with a bunch of definitions. So first let's review the definition of rotation. Okay, and I'm going to give you a slightly different definition than the first one, but they're equivalent. Rotation is an isometry that moves every point in the plane around a fixed center point, and it moves them in a circular motion. Okay, that is the definition of rotation. Now there's a whole bunch of definitions, so many that I'm not going to be able to fit them on this paper, and you should write these in your notes on a separate page. We're going to talk about various forms of symmetry. We're going to start with rotational symmetry. Okay, rotational symmetry is when an object has rotational symmetry if there is a center point around which the object is turned or we could say rotated a certain number of degrees and the object looks the same. Okay, now we also have a definition for something called the order of rotational symmetry. The order of rotational symmetry is the number of positions in which the object looks the same is called the order of the rotational symmetry. And there's a little bit more to this. When determining the order of rotational symmetry, the last rotation returns the object to its original position. Therefore, order equal an order of 1 implies no true rotational symmetry. since a full 360 degrees rotation was needed. Okay, so if you have to turn the object entirely around to come back on itself, and that's the only way you can rotate an object so that it looks the same, then there really isn't any rotational symmetry, and the order is 1. Let's go on to another equivalent term that we're going to need sometimes, which is called the degree measure of rotational symmetry. So the degree measure of rotational symmetry is the smallest number of degrees that an object can be rotated around its center point that makes the object look the same. Okay, so if you have an object and you could rotate it in many different degrees and it will look the same, the smallest of those degrees is called the degree measure of rotational symmetry. It is equal to 360 degrees divided by the order of rotational symmetry. Okay, so this is an important fact that the degree measure, let me write that again here, degree measure of rotational symmetry equals 360 degrees divided by the order of rotational symmetry. Okay, so that if we know, for example, that the order of rotational symmetry is 10, so let's say, here's an example, we know that the order of rotational symmetry is equal to 10, then what would the degree measure of rotational symmetry be? It would equal 360 divided by 10, or 36 degrees. Okay, still another pair of definitions that we need to know. We've talked so far about rotational symmetry, and this is a unit that's primarily about rotations, but we did discuss a lesson or two ago about line symmetry, and we need to review some definitions about line symmetry. So line symmetry we say that if you can reflect, or we could say flip over, a little bit more colloquially, if we could reflect or flip over a figure across a line, and the figure appears unchanged, then we say that that figure has reflection symmetry or line symmetry. Okay, they mean the same thing. And then just like we had for rotational symmetry, we have an order of line symmetry. And what we say here for the order of line symmetry is that the number of distinct lines that are lines of symmetry is the order of line symmetry. Okay, so we are going to, at times, need to know how many distinct lines exist that are lines of symmetry.